Okay, next is question number 17. Okay, in question number 17, the question says the photograph shows a floating object called buoy. Okay, a long chain attaches the buoy to a very large mass at the bottom of the sea, so that the buoy remains what? Stationary. Okay, so a buoy, it's an object, okay, that is floating on the water surface. Okay, water flowing past the buoy causes a horizontal force of 260 Newton on the buoy. The chain exerts a force F on the buoy at an angle of 33 degree to the vertical as shown. So the force F, okay, this is basically the tension force on that is acting on the buoy from the chain. Okay, so this is acting at an angle of 33 degree to the vertical. We can see in the figure. So part A1, it's asking here to show that F is about 500 Newton. Okay, we need to show that F is basically what? 500 Newton. So this is pretty simple. You can understand it here that F is basically what? If you consider the vertical component, right, and consider the forces acting on the buoy vertically, you can easily find out the force F, right? Okay, so before we consider the weight, we don't know the mass, right? So we have to consider it horizontally. That's better, isn't it? Because weight is unknown. Weight we don't know. So consider the forces horizontally. If you consider the forces horizontally acting on the buoy, what you will get? The horizontal component of the force F. This is what? This is basically, look, this is basically F sine 33 degree, right? So F sine 33 degree, this is equals to what? 260 Newton. That's the horizontal force that is acting due to the current, water current, right? So the value for F, this is 260 over, keep in mind your calculator should be in degree mode. So sine 33 degree, that would give you 260 over 33. Okay, so that gives 477.380.3993 Newton. Okay, so which can be rounded to 500 Newton. That's what part A1 has asked for. Fine. Okay, next is part 2. Okay, part 2 of A from question number 17. Okay, so here in part 2 of A, question number 17, the question is asking, saying the buoy floats due to the upthrust from the water. The weight of water displaced by the buoy is 2.9 kilonewton. Determine the weight of the buoy. Okay, so we need to find out the weight of the buoy. Okay, so the question says the buoy is basically floating due to the upthrust. So upthrust, it's equal to what? The upthrust, it is equal to the weight plus the vertical component of the force F, isn't it? Right? So the vertical component of force F, it acts vertically downward. Upthrust is acting upward. Okay, and its weight is also acting what? Downward. So what we can consider? Consider the forces vertically upward that is acting on the buoy. Okay, so upthrust is what? The weight of water displaced by the buoy, it is 2.9 kilonewton. We know that upthrust is what? It's basically the weight of the displaced fluid, right? So this is what? 2.9 kilonewton, right? So 2.9 times 10 cube, that much Newton. This is equal to the vertical component of force F. So vertical component of force F, that would be what? 477 point something cos 33 degree. Okay, so 477.380 cos 33 degree, right, plus W. Okay, so W would be what? Weight would be okay, 477.380. It is saved in my calculator since we did it just in part 1. So answer times cos 33 degree, then 2.9 times 10 cube, 2.9 times 10 cube minus the 477.380 cos 33 degree. So that would give you 2499.635. Okay, so 2499.635109 Newton. So weight, okay, weight of buoy, they have given a blank space here to write, so we can write it to three significant figure, which is three significant figures, it gives 2500 Newton. Okay, so we got the weight of the buoy, it is what, 2500 Newton. That's it. That's what part 2 of question A from question number 17 has asked for. Fine. Okay, next is part B from the question number 17. Okay, here the question says the speed of the water flowing past the buoy increases, so the horizontal force increases. Okay, the horizontal force acting on the buoy increases. Assume that the weight of water displaced by the buoy does not change. Okay, so this is basically what, the upthrust, right? Because weight of displaced fluid, it is called upthrust. Okay, so upthrust does not change. This is an important point. Okay, explain how F and theta change when the horizontal force increases. Okay, so if the horizontal force increase, then how it will affect the force F, that is the force from the chain, and its angle with the particle, right? So now consider how it will affect the force F and theta, where theta is the angle between the force F and the particle. Okay, so in that case, we know that the buoy has to be at rest, that is in equilibrium. So in equilibrium, the force, if the horizontal force increases, then to keep the buoy in rest, the horizontal component of force F should also increase, right? So if you consider the horizontal component of the force F, okay, before considering the horizontal force, okay, just we need to consider one thing. They said at the beginning, assume that the weight of water displaced by the buoy does not change. That means the vertical, in the vertical direction, the upthrust is acting, it is remaining constant. That means vertically, the vertical component of force F should remain as it is. It should not change, right? Because the upthrust, it's not changing. Okay, so what we can say is that at first, the first point is that the vertical component F vert, the vertical component of force F should remain constant as what? F, the force upthrust is constant, right? Okay, because the buoy has to be in equilibrium both vertically and horizontally. So since vertically upthrust is not changing, so the first point we said that the vertical component of force F should remain what? Constant, because upthrust is constant. Okay, fine. Now consider the horizontal dimension. Okay, so horizontally, what we can say, sine theta. Let's consider the horizontal component of force F. Okay, so this can be related by what? Sine theta. Okay, so if you write sine theta, okay, rather than sine, okay, we can consider sine theta. So if you say sine theta equals to what? The horizontal component of force F over the resultant F. Okay, so the horizontal component of force F. This is what? F sine theta. Okay? As horizontal force increases, F and theta should increase. Okay, F and theta should increase to keep the buoy in equilibrium. Okay, now there's a concern. The concern is that horizontally it is fine. If horizontal force increases, then F and theta should increase to keep the buoy in equilibrium. That's fine. But if theta changes, then we know that theta, the vertical component of force F, will get affected, right? So vertical component of force F is what? F cos theta, right? So if you consider the vertical component of force F vert, vertical component of force, it is what? F cos theta. So if theta increases, we said what? Theta increases and also F increases, right? So if theta increases, then we know that the value of cos theta basically decreases, right? So basically the vertical component of force F is remaining what? Constant. Okay, so you can give a reference here. F vertical should remain constant, as F upthrust is what? Constant. So we can give a reference here, which is F vertical. This is equals to what? F cos theta. So according to our conclusion that F increases, F and theta both increases. So if theta increases, cos theta decreases, and F, we said F increases, so basically it is getting balanced and keeping the vertical component of force F what? Constant. Okay, so that's enough. That's all about part B of question number 17 from the May 2023 Physics Unit 1 paper.